Previously, you calculated the number of carbon atoms in a cube of sucrose, that is C12H22O11. For example, that if the cube was 2.3 grams, we divided it by its molar mass, that's 12.01 times 12, plus 1.008 times 22, plus 16 times 11. This gives us 0.006719 moles of sugar per cube. With some fancy calculations, the number of atoms of each element present can be obtained. The formula for sucrose tells us the ratio in which the atoms are present. So for every 12 carbon atoms, 22 hydrogens and 11 oxygens are needed, in a ratio of 12 to 22 to 11. Sometimes we need to know the ratio of elements by mass in which the elements are present. This is called the percentage composition. But why? Well, farmers particularly may want to know which fertilizer has the most nitrogen in it. Let's take a look at a common example. If 2.05 grams of magnesium is placed in a crucible and allowed to react with oxygen in the air, when the blinding light stops, we know the reaction is complete, and the equation for this reaction is like so. When the chemical reaction is complete, the mass of the magnesium oxide works out to be 3.48 grams after all the calculations. By subtracting the mass of the oxygen added, it must be 1.43 grams. Now, ratios work on the basis of moles, so we must convert both the masses of the magnesium and oxygen into moles, so here goes. The moles of magnesium is 2.05 grams over 24.31 grams per mole, which equals 0.0843 moles. Moles of oxygen is 1.43 grams divided by 16 grams per mole, which equals 0.0894 moles. As a ratio of 0.0843 to 0.0894, divided by the smallest number, which gives a ratio of 1 to 1.06. That's very close to 1 to 1. So the ratio of magnesium to oxygen is 1 to 1. That is, for every magnesium atom, there is one oxygen atom in the empirical formula of magnesium oxide. So it's written as MgO. Now, if your mole ratios are looking funny, like crazy amounts of decimals, just multiply each by the same number that will give you a whole number. Easy as.